Hey everyone, welcome back to another video here on Try Hack Me. I'm John, and today we'll be taking a look at the room OSI model. Learn about the fundamental networking framework that determines the various stages in which data is handled across a network. The OSI model in general, and we'll go into this in just a moment, is a network that can be used for troubleshooting and sort of breaking down what actually happens on the cables, and furthermore on the actual computer itself when it's trying to talk across these networks. That being said, let's go ahead and dive right into task 1. What is the OSI model? The OSI model, or Open Systems Interconnection Model, is an absolute fundamental model used in networking. This critical model provides a framework dictating how all network devices will send, receive, and interpret data. One of the main benefits of the OSI model is that devices can have different functions and designs on a network while communicating with other devices. So it doesn't matter what the device is, as long as it obeys this model, it still works, and it can still send and receive data across this network. Data sent across a network that follows the uniformity of the OSI model can be understood by other devices. The OSI model consists of 7 layers that are illustrated in the diagram below. Each layer has a different set of responsibilities and is arranged from layer 7 to layer 1. At every individual layer that data travels through, specific processes take place, and pieces of information are added to this data, which is what we'll come to discuss in the upcoming tasks within this room. However, for now, we only need to understand that this process is called encapsulation and what the OSI model diagram, or it looks like in the diagram below. And here you can see these 7 layers. We have physical, data link, network, transport, session, presentation, and application. Let's go ahead and answer the questions below. What does the OSI in OSI model stand for? That is Open Systems Interconnect. It might be interconnection. There we go. How many layers in digits does the OSI model have? That will be 7 layers, and we can see them above. What is the key term for when pieces of information get added to the data? That is encapsulation. Let's go ahead and move into task 2, layer 7, application. Layer 7, application. The application layer of the OSI model is the layer that you will be most familiar with. This familiarity is because the application layer is the layer in which protocols and rules are in place to determine how the user should interact with data sent or received. Everyday applications such as email clients, browsers, or file server browsing software such as FileZilla provide a friendly graphical user interface, or GUI, for users to interact with data sent or received. Other protocols include DNS, Domain Name System, which is how website addresses are translated into IP addresses. And you can see just an example of interfacing with an FTP server, File Transfer Protocol. What is the name of this layer? This is the application layer. What is the technical term that is given to the name of software that users interact with? That is a graphical user interface. And there we go. Let's move on to task 3, layer 6, presentation. Layer 6 of the OSI model is the layer in which standardization starts to take place. Because software developers can develop any software, such as an email client, differently, the data still needs to be handled in the same way, no matter how the software works. This layer acts as a translator for data to and from the application layer, layer 7. The receiving computer will also understand the data sent to the computer in one format destined for another format. So, for example, when you send an email, the other user may have another email client than what you have, but the content of the email will still need to display the same. Security features such as data encryption, like HTTPS when visiting a secure site, occur at this layer. What is the name of this layer? That is the presentation layer. What is the main purpose that this layer has? That is standardization, if I can spell it correctly. Not even close. Wow. Let's copy that, and we're going to paste instead of me trying to spell things. Or we're looking for translator, rather. Give me a moment. And we're just going to ignore that I can't spell. And it got even worse. Wow, we are getting worse by the second. Okay. Perfect. Let's move on to task 4, layer 5, session. Once data has been correctly translated or formatted from the presentation layer, the session layer will begin to create a connection to the other computer that the data is destined for. When a connection is established, a session is created. Whilst this connection is active, so is the session. The session layer, layer 5, synchronizes the two computers to ensure that they are on the same page before data is sent and received. Once these checks are in place, the session layer will begin to divide up the data sent into smaller chunks of data and begin to send these chunks, packets, one at a time. This dividing up is beneficial because if the connection is lost, only the packets that weren't yet sent/received will have to be sent again. Not the entire piece of data, so think of it as loading a save file in a video game. What is worthy of noting is that these sessions are unique, meaning that the data cannot travel over different sessions, but in fact only across each session that it's specifically destined for. Let's move into the questions. What is the name of this layer? It is the session layer. What is the technical term for when a connection is successfully established? It should be, let's see, I'm guessing created. Let's go ahead, I'll pause this for just a moment and double check my notes. All right, there we go. So we're specifically looking for the term session. So that's saying that the connection has been established and we've created a session. What is the technical term for small chunks of data? That is packets. And there we go. Let's move into task 4, layer 4, or task 5 rather, layer 4, transport. Layer 4 of the OSI model plays a vital part in transmitting data across a network and can be a little difficult to grasp. When data is sent between devices, it follows one of the two different protocols that are decided based on or upon several factors. So we have TCP and UDP. Let's first begin with TCP. The Transmission Control Protocol, otherwise known as TCP, is a protocol that it's meant for reliability in transport, and we'll get into that in just a moment. Potentially hinted by the name, this protocol is designed with reliability and guarantee in mind. This protocol reserves a constant connection between the two devices for the amount of time it takes for the data to be sent and received. Not only this, but TCP incorporates error checking into its design. Error checking is how TCP can guarantee that data sent from the small chunks in the session of layer 5 has been received and reassembled in the same order. So we have accuracy of that data being transmitted. Let's summarize the advantages and disadvantages of TCP in the table below. So, some advantages. Again, this guarantees the accuracy of the data because we're checking it once it's received on the other side. It's capable of synchronizing two devices to prevent each other from being flooded with data, and it performs a lot more processes for reliability. Disadvantages, this requires a reliable connection between the two devices. If one small chunk of data is not received, then the entire chunk of data cannot be used because we have to resend that packet. Another slow connection can bottleneck another device, as the connection will be reserved on the receiving computer the whole time it has to be active. TCP is significantly slower than UDP because more work has to be done by the devices using this protocol because we're checking things and maintaining that connection. TCP is used for situations such as file sharing, internet browsing, or sending an email. This usage is because the services require the data to be accurate and complete, and there's really no good in receiving half of a file. In the diagram below, we can see how a picture of a dog is broken up into smaller pieces of data known as packets from the web server, where the computer reconstructs the picture of the dog in the correct order. So it's broken up into these packets. In theory, these would be a lot smaller than this, and we can see how it's finally reconstructed at the endpoint. Now let's move on to User Datagram Protocol, or UDP for short. This protocol is not nearly as advanced as its brother, the TCP protocol. It doesn't boast the many features offered by TCP, such as error checking and reliability. In fact, any data that gets sent via UDP is sent to the computer whether it gets there or not. There is no synchronization between the two devices or guarantee, just hope for the best and fingers crossed. While this sounds disadvantageous, it does have its merits, which we'll lay out on the table below. So it's much faster than TCP. A lot of this is kind of the inverse of what we saw with TCP, so a lot faster. It leaves the application layer user software to decide if there's any control over how the packets are actually sent. UDP doesn't really care. It's up to the actual user software to kind of decide that from there. And UDP doesn't reserve a continuous connection, so it doesn't bottleneck the device there. Disadvantages, it doesn't really care if the data is received. It's going to send it anyways, and it's going to keep on going. It is quite flexible to software developers in this sense, which is good and bad. It depends on how it's implemented. The biggest thing to think of with UDP is something like Skype or video calls, which UDP is perfect for, because you're sending a lot of data, and maybe you hit a little small hiccup that the video connection doesn't quite, it might make you sound like a robot for a little bit, or things like that. But you just wanted to keep moving on, because you don't want to see something from, 5 minutes in the past suddenly flash on the screen. That might be terrifying. But in this case, you wanted to keep moving, and that's the idea with UDP. You want that data stream to keep continuing. And with it not reserving that connection, this means that on unstable connections, it might be a bad experience. And you've probably seen this before when Skype was first coming out, that it wasn't always great. It wasn't always a great connection. And even then, sometimes you can see that with streaming services like Netflix or other things, where sometimes you just hit a rough patch in the internet that a lot of people are on, and all of a sudden your connection just doesn't really work that well. Using the same example as before, we can now see that only packets 1 and 3 have been received by the computer, and you end up with this horribly disfigured dog. And you can see how UDP can sometimes not always be the best choice. UDP is useful in situations where there are small pieces of data being sent. And we mentioned here that video streaming are really large files where it's okay, maybe if you're watching a video on YouTube, that it's okay if part of the video is pixelated because it'll pick itself up here in just a little bit. That happens, and that's where UDP is really useful. Let's go in and dive into the questions. What is the name of this layer? Gotta double check what layer we're on. Transport, there we go. What does TCP stand for? That is Transmission Control Protocol. What does UDP stand for? That should be User Datagram Protocol, if I have that typed correctly. What protocol guarantees the accuracy of data? That will be TCP. What protocol doesn't care if the data is received or not by the other device? That will be UDP, because we're not actually checking it when it's received. What protocol would an application such as an email client use? That hopefully is TCP. What protocol would an application that downloads files use? That would be hopefully TCP as well, if you want to guarantee that you're receiving all of the data and it's correct. And what protocol would an application that streams video use? Like the UDP. All right, let's go ahead and move on to task 6, layer 3 network. The third layer of the OSI model, the network layer, is where the magic of routing and reassembly of data takes place, from these small chunks to a larger chunk. Firstly, routing simply determines where the most optimal path in which these chunks of data should be sent. So maybe we have multiple routes to our destination. Routing is going to determine which one is going to be the most ideal, or typically the fastest. While some protocols at this layer determine exactly what is optimal, or what is the optimal path rather, that data should take to reach a device, we should only know about their existence at this stage of the networking module. Briefly, these protocols include OSPF, or Open Shortest Path First, RIP, or Routing Information Protocol. RIP is really common to see. Don't worry about this too much. You can do different forms of attacks based on this, but we won't worry about that at this point. Just know that they exist. The factors that decide what route is taken is decided by the following. So what path is the shortest? So for example, has the least amount of devices that the packet needs to travel across. What path is the most reliable? So have packets been lost on that path before? And then last, which path has the faster physical connection? So for example, if one device is using a copper connection, which would be slower than a fiber connection. So it's going to take these factors into consideration when determining how it's going to actually send things across. At this layer, everything is dealt with via IP addresses such as 192.168.1.100. Devices such as routers capable of delivering packets using IP addresses are known as layer 3 devices because they are compatible at working at the layer 3 of the OSI model rather. So again, routers are going to be the big one here that live in this layer because that's where you have IP addresses taking place. What is the name of this layer? It is going to be the network layer. Will packets take the most optimal route across the network? Hopefully. What does the acronym OSPF stand for? We're going to go ahead and copy that up here. Open shortest path first, which fairly straightforward. What does the acronym RIP stand for? That is the Routing Information Protocol, and we can copy that again. What type of addresses are dealt with at this layer? That is going to be IP addresses. This is where logical networking takes place. And make sure you have plural on that. Let's move into task 7, layer 2, data link. The data link layer focuses on the physical addressing of the transmission. It receives a packet from the network layer, including the IP address for the remote computer, and adds in the physical MAC address of the receiving endpoint. Inside every network-enabled computer is a network interface card, or a NIC, which comes with a unique MAC address to identify it. We talked about this in the previous room. MAC addresses are set by the manufacturer and literally burnt into their card, and they can't be changed, although they can be spoofed in this case. When information is sent across a network, it's actually the physical address that is used to identify where exactly to send the information. Additionally, it's the job of the data link layer to present the data in a format suitable for transmission. What is the name of this layer? It is the data link layer. There we go. What is the name of the piece of hardware that all network devices come with? That is going to be a network interface card, or a NIC. Perfect. Let's go ahead and move into task 8, layer 1, physical. This layer is one of the easiest layers to grasp. Put simply, this layer references the physical components of the hardware used in networking and is the lowest layer that you will find. Devices use electrical signals to transfer data between each other in a binary numbering system, so ones and zeros. One quick note, there is an ongoing networking joke that layer 0 exists, and it is the human layer, so if you have a layer 0 problem, it's the human that's involved. So if you ever see that come up, that's what that's referencing. For example, Ethernet cables connecting devices, such as the diagram below, so this would be part of the physical layer. Let's dive into the questions. What is the name of this layer? It is the physical layer. What is the name of the numbering system that is both zeros and ones? That is binary. What is the name of the cables that are used to connect devices? Ethernet cables. And there we go. Let's move into task 9, practical OSI game. Can you escape the OSI dungeon? Climb the levels in the correct order to escape the dungeon and reveal the flag. Can you beat our staff high score of 19 seconds? Definitely recommend trying for that. For the sake of the video, I'm not going to be speedrunning through this. I'm going to walk through and explain everything as I do it. But that being said, let's go ahead and dive right in. OSI dungeon, insert coin. This is wonderful. Our hacker has been locked in the dungeon. Their only chance of freedom is by choosing the correct path based on the OSI model. Use your cursor keys to move left and right, and the spacebar to enter the doors. So let's see. I believe I'm here at the bottom, so we're starting with layer 1. Maybe. Let me go ahead and pause, and I will make sure that this is working for me. Alright, there we go. I have a 60% keyboard, so I have to remember which keys are the arrow keys. So first off, we have the physical layer. So space to enter that door. And then we have the data link layer of number 2. And there we go. And then we have the network layer. Perfect. And then we have layer 4, the transport layer. Next we have layer 5, session. And let me go ahead and scroll up just a little bit. I've got this zoomed in so that you guys can see. Next we have layer 6, the presentation layer. And finally we have layer 7, the application layer. And there we go. Perfect. Well done. We've escaped the dungeon in 74.18 seconds. Wonderful. I'm very fast at this game, as you can tell. Let's go ahead and type in our flag. OSI dungeon escaped. And there we go. Let's go ahead and move into task 10, continue learning with packets and frames. Continue your learning by joining the packets and frames room. we'll go ahead and mark that as complete. I highly recommend moving on to that room after this video. If you want to, you can go and continue practicing with the OSI game here, and I definitely recommend doing that as well. As always, if you have any questions, I will have the TryHackMe Discord and subreddit linked in the video description below. But otherwise, I'll see you in the next video, and until next time, happy hacking!